So in this example here, we have a polynomial function f as represented by the graph, and we want to determine the minimum value of this graph f. So you might not be able to recognize what this graph, again, what type of function this is. F of x is equal to some power of x to, again, some value of x to some power, okay? So in order to determine what the smallest exponent this would have to be, we're going to look at the number of times that this thing turns. So we count them here from left to right. This is a round turning point, 2 and 3. And all we have to do is just simply add 1 to that value. So since there's 3 turning points, 3 turns, 3 plus 1 is 4. So that means that the degree of this thing has to be at least a minimum of 4. Meaning that the equation for this would have to be some value of a times x to the power 4 plus some value of b times x to the third power, some value of c times x to the second. We'll use the letter d times some power x, and then a constant at the very end. We'll just call it e. Now, some of these numbers could be 0, and we might not have some of these terms there. But in terms of a minimum, the smallest one would have to be 4. We cannot start with an x to the third power and move from there, or an x to the second power and move from there. It has to be an x to the fourth power at minimum, okay? At least that. It could be that we start off with 5, so 5, 4, 3, 2, 1, and then we have to add another 1 right there, okay? So it could be that. It could even be 6, 5, 4, 3, x to the second, and then until we get to the constant. But like I mentioned again, at minimum it would have to be 4 because of the 3 turning points plus 1 more. We always add 1, and that would give you the minimum degree.